take people where they are. So yeah, if you're interested in a career in C++, working with the Photoshop team, drop us a line. So, a while ago now, about 2 years ago now, I was working on a project. It was a proof of concept, kind of in the Lightroom space. I had been working with the Lightroom team. I'm one of the people who brought the Lightroom rendering engine to mobile devices and then to the web browser. And I worked with the group to do a proof of concept. And at the last minute, kind of the rug got pulled out from under it. It was a very depressing time. So 2 people left the company over it. One of those political things that happen in a large company. The project was killed. And so I was sitting in my office, and I had agreed to wrap up some stuff with the Lightroom team, and then I was looking at what I was going to work on next. And Dave Howe walked into my office, and Dave was a product manager, and had been a QE manager when I was on the Photoshop team. He and I had worked together for a number of years. And he walked into my office and said, "So, could we just put Photoshop on the iPad?" And I thought about it for a minute, and I said, "Yeah, I think I know how I'd do that." I said, "Let me go talk to a guy, Sita, who's been on the Photoshop team since before I joined Adobe. I've been there 25 years now." So I went and chatted with Sita, and Sita said, yeah, he had been thinking along the same lines. In fact, he had started a small proof of concept, but couldn't get anybody to get behind it. And so he said if I could get some resources behind it, he wanted in on this project. We roped in a third person, Michael Kaplan, and then put together a pitch and tried to get some running room for the 3 of us to go do a proof of concept. And at first the answer came back as a no, which I thought was kind of surprising. We had 3 senior people who thought that this was doable, thought we could go do a proof of concept, basically knew the approach, we just didn't know for sure that it would work. But that got turned into a yes. It took us about 4 months to get the first proof of life coming up, and I think we kind of hit it out of the park. It was a pretty impressive piece from day one. So just this one little statement kind of kicked off this whole series of events. So how many people here have used Photoshop? Most people use Photoshop. It's a pretty big app. Here. So this is a Photoshop document. This is, in fact, a fairly massive Photoshop document. If you look down here in the corner where my cursor is, it's 2¼ gigabytes for this document. If we look at the layers palette here, I should have had that one. I did. Oh, I do. It's way down here. So much in the UI. This is bigger. So the layers palette is down here. You can see if I scroll through it, this thing is a huge document with a lot of components all composited together. It's actually something that Adobe put together for an advertising campaign. So it's kind of a ridiculous image, but it's a massive document. Now, I switch over. Switch to export. Fails to connect and have the problem. So this is the same document on my iPad Pro here. Sorry to make it all busy. So you can see all the layers are there. It's exactly the same document. And through. We could zoom in. Get all the way in to look at every last pixel. Zoom all the way back out, all the way back in. At any point in this document, you'll find it's super smooth regardless of the zoom level. And to show that this is not just a canned image, let's go up here and find the bear. I know he's near the top. I already have them selected. So we got the bear tool, bear, we can pick him up and we can slide him around. And you can see he's composited live, so he's like behind the badger, and behind the wood over here, and behind the raccoon. It's live compositing inside the app. So that's all well and good, but this is a brand new iPad Pro, so this is a pretty spiffy little piece of hardware. So brought another piece of hardware. This is not the same document. I can't open the document on here. It's just not particularly usable. So this is an iPad Mini 2, which is a 1 gig device, 2 cores, shipped from Apple about 5.5 years ago at this point. So a fairly ancient device by today's standards. This document is not quite the same size, but you can see it's a non-trivial document here. We've got a number of layers going on in here. This is about 1 gigabyte. There's only 16 gigabytes of storage on here, so we start to burn through the SSD if I open the big wolf bear image on there. But this is still a professional quality document here. We can zoom in, we can pan around. So you can zoom in and see every last pixel if you want. This is still updating. You can see the pixels are misaligned there for a moment. And here you can kind of catch the grid. So you can see this is a slower device. But it's still very usable. And we could even make a quick edit here. Like that. Make a room, look at the sky. Got a hole in the sky here. Take that selection and mask it out. You see the asteroids are in front of that hole. We've got our brushing tool here, which includes all of the Photoshop brushes. Open that up. Oops. We do have full undo. Texture there. Cheesy moon for image. So that's Photoshop on an iPad on a very low-end device. So how do we do this, right? We took this massive desktop application and got it running, and you can see from the complex document we have full fidelity. Desktop, those are both PSD files going through. So, this is Photoshop with all the palettes open. It's a very large app. This image is actually the second image we ever opened up on an iPad device. The first one was a blue rectangle. And we said, hey, blue rectangle, we're going to try this one. We crashed the first try. The second try, it opened. That's an advertisement that Nissan did, so it's professional quality. So here was the challenge. So Photoshop is huge, it's complex. There is no explicit model. I mean, we'd like to say that it's model view controller pattern, but there really is no explicit model. What do I mean by model view controller? Right? It's not just the data. Right? A model should be the data, the constraints and relationships on that data. all packaged into some observable form, right? If you go back to the Smalltalk papers on model view controller, when they were talking about a model, that's what they were talking about, right? It's not just your data model, it's the data, the constraints and relationships on that. Because it was Smalltalk, you could bind against it, and it was this observable set of objects, right? So the realization that I had looking at this was, okay, fine, we don't have a good model. So the UI is the model. So what did we do? We took Photoshop with this huge, massive UI, and we stripped away the visual appearance of the UI. Okay. We left all the constructs in place. So if I brought this up in Xcode and I stepped through them in the debugger, you would see that all the constructs for all of those palettes and all of those widgets are there in the debugger under the hood. You can't see necessarily all of them in the UI yet, but they're all there. Okay? And in place of things like having a platform checkbox that you could go click on, now we have a bindable boolean, okay, that you can attach to, and you can say, hey, tell me when this checkbox is on, tell me when it's off. I can set it, and that might cause a cascade of logic inside the application where it sets other values, right? So the constraints and relationships that are inside the Photoshop model were all captured up in the UI. Ideally, that wouldn't be the case. Ideally, you'd have a pure model that you just rebind against. But Photoshop is almost 30 years old, so it just wasn't written that way to begin with, and even though people have tried to evolve it in that direction over time, it's never gotten there. So we captured the whole thing. We just stripped off the very top surface. So that gave us the ability to bind to and observe all of the UI elements. And we didn't have to go and construct the UI in advance, because what Photoshop would do when in its normal course of execution is if the code needed a value from the UI, is it would say find subview, right? Give me that checkbox and find it. And the code would never try to find something that didn't actually exist. So we said, well, we don't have to like read in all these resources and construct some whole dummy UI in advance when the application launches. As the application goes and queries for the UI, we'll construct it then. If it says, find me a checkbox, we'll say, yeah, here is a checkbox. Here you go. Okay. In the same way as the surface is talking to it, if the surface says, I want to check this checkbox, we say, well, there wasn't one there before, but we'll make one. So we pull things up in a lazy fashion. So that kind of solved the observable model part. But the other part that we had is that Photoshop on the desktop is not a particularly fluid application. It was written initially as a single-threaded application. The threading support that was added, for the most part, was added down at the low levels of the image processing code. So Photoshop slices up your image, and using like Gaussian blur your image or something like that, it slices it up into, well, it's already got it sliced up into a bunch of tiles, but it will take a tile and subdivide it for the number of cores you have, and go and say, apply the Gaussian blur to each of these slices on the number of cores you have, and then stitch those all back together and put those up on the display. So that's how it gets performance, but that doesn't give it good interactivity. The interactivity that's there is largely done by queuing tasks back to the main event loop and letting them execute. But on a touch device, that feels incredibly laggy. Right? You really want a touch device to just be fluid and to just track your fingers. So we said, okay, well that's not going to work, right? So what do we want to do? The answer here was we said, well, take all of Photoshop, since it's got no head, it's not good, it doesn't have any ties to the actual UI layer. Take all of that Photoshop that's single-threaded and give it its own thread. In fact, initially we did it as just a serial queue executed inside of a thread pool, but because there's a couple places in Photoshop where it would re-enter the main event loop, basically putting it on a serial queue doesn't quite work. It did for the initial prototype. We've got a plan to go and transform the architecture of Photoshop to make that work. But right now it's running off on its own dedicated thread. So now we've got basically a headless Photoshop server running in the background. Right? And that frees the UI thread to be responsive to the user and to interact directly. One hard goal that we have with this project is no blocking between the two threads. To date, we do not have a single condition variable that says, like, okay, wait until one side or the other completes with something. We do have a couple places where we have mutexes, right? But they're usually very narrow windows where we have to share a code so they can hand off communication between the two, right? But absolutely no condition variables between the two threads. So the two sides are running independently. Okay. We refer to this Photoshop running on its own thread as the Photoshop core. So if you have a core, the next thing we had to build was the mantle, right? How you talk to this thing in some reasonable way. So the mantle is an API layer that presents an observable shadow model of the application. Right? So now we've got this observable model running in core, but we need to attach a surface to it, and so that has to bind against something. And so our mantle handles the asynchronous behavior, and so we have a shadow model that's potentially out of sync with the core model at any point in time. But the two are guaranteed to always converge. About that in a moment. That's our mantle. The model that the mantle presents is a containment hierarchy as opposed to the view hierarchy that we have in core. So we've got an application that contains a collection of documents. Documents contain layers, and so on and so forth. So each of these object types, like documents and layers, have sets of properties. Those properties present a fairly rich interface. Right? We have read-only properties. We have disableable properties, which are dynamically read-only. You can connect to these things with a slot signal-like mechanism. So you can monitor the state of them. You can monitor the disabled state of something. And we have an auto-disconnect mechanism so that as you connect to them, as objects on one side or the other go away, they auto-disconnect in response to signals. So the mantle itself manages high-speed communication with the core. Communication is handled by sending code, which is a term that I use a lot to explain this to people in kind of the older people on the Photoshop team, myself included, who've been around for a while. But when I said our communication mechanism is we just send lambda expressions back and forth. Right? People are like, what? So we basically send code, right? Instead of packaging and serializing everything up into say a JSON format or something to communicate with this Photoshop server, we just say execute this block of code within the Photoshop context. And from within the Photoshop context, if it wants to send something back, it says execute this block of code within the service context. Okay, so there's no serialization or deserialization overhead. This is what a typical communication call might look like. This would be a very simple one. So core invoke, so send this function over and invoke it on the core side. Okay. You can capture items, so in this case we capture a file type, which come from an argument within the UI. Now the core document that gets repeated here, right? You see it's passed as an argument to core invoke, and then it gets passed on as an argument to our lambda expression there. Right? A T-image document is an old legacy core piece of thing. Right? Photoshop is written in kind of NACAP style, object-oriented programming. Some things are smart pointers, some things are still not smart pointers. So things tend to be talking about things with pointers a lot. But you have the problem here when things are running asynchronously of how do you know that that object still exists on the other side? So if it's a shared pointer, we could take a weak pointer for it, in which case this core document would be a weak pointer. If it were an Objective-C strong pointer, we can take an Objective-C weak pointer to the thing. And if it was neither of those, you can augment the class by inheriting from something that we call trackable from this, okay, which lets you essentially take a weak pointer to it, but there's no ownership semantics on those kind of pointers. It's just something that auto-nulls when that thing destructs. So on one side or the other, you're holding on to some form of a weak pointer token to what's on the other side. You pass that in when you want to invoke, and this whole thing becomes a no-op if that thing has gone away on the other thread, right? So if it hasn't gone away, then it's resolved into the pointer, and now we can safely dereference it here. We know we've got a valid pointer. We don't have to check for null there. And we can go ahead and save our document with the right file type. Right, so that's that piece. So that sends the message off over to core. Now, something else happens here. The message that we send to core immediately get reflected back to surface. We assume success of basically everything we do. So in this case, if you were setting a document, the thing that might get set back is to say the document is saved. That is done. Immediately, before the message has even reached core. Okay? So that's what this transaction is about. So what happens is for each property, a property gets stamped with a transaction ID. And the associated message that was associated with setting that property, that message, that transaction ID gets sent through this, that gets sent to core. I'll explain it better here. They allow for simple speculative execution, they're self-correcting, and it's a similar model to Apple's core animation. I don't know how many people have used core animation? Nobody. If you ask me, like, why are iOS products so nice to use compared to everything else in the marketplace, Apple's secret sauce is core animation. And the model with core animation is if I say, take this button on the screen and set its location to be +100 pixels. It's just an API call. I say set it, and as a developer, if I said where is it now, I would get back it's at 100. But in reality, it isn't there yet. Okay, it's started an animation automatically to transition over there. Okay. And if I made a series of calls and said set it to be 100 and set it to 200 it might never actually reach 100 It will arc off and go to the next point that I want. Okay? So as a developer, I have this very simple model where I can write data and read data, and everything seems to be completely sequentially consistent from my view. It's not the same view as the actual world view, but I'm guaranteed that the two will eventually settle out in the same place. So we do that with basically everything, all of the properties within the document. So, from the programmer's view and the user's view, everything is instantaneous, even though there can be massive underlying latency. So when a property is changed, the change is reflected immediately, and the property is stamped with a transaction count. The count just keeps incrementing. Each property change message from mantle to core is associated with the transaction count. So the transaction send it down. The transaction ID is stored in a thread local scope so that we can pick it back up automatically for any messages coming back the other way. Globally available to any notifiers, and notifications from core to mantle echo back the count. If a mantle property receives an update with a count less than the property count, the update's ignored. Right? So if I get a message back from core, say I've got a checkbox, my checkbox is at state 42, if I get a message back at state 41 that says the checkbox should be false, but I'm at 42 and it's true, I just ignore it. They haven't processed 42 yet, right? So if I flickered, I'd be basically going back in time. The user was clicking on things quickly and I'm catching up, okay? So I don't refresh the UI until the numbers match or are higher. So if I'm at 42 and I get back a message at 42, my state was true, but the message coming back says, oh no, it's really false. Okay? Then I will update my state then. So that gives me this way that my UI is going to run out in front of the core, be super responsive to the user, and if any mistakes are made, the system will just self-correct. Okay? As a user using it, I guarantee you'll never notice it. right? But you would notice it if we waited for everything to run through. You would certainly see the labels. Transaction class is super simple, right? All we have here is a little static function to give us a next ID. Reads an atomic. We can have multiple threads talking. Okay. We've got a thread local that'll give us the current ID. And if you construct a transaction scope, you give it an ID. Okay. And what does it do? It takes the current guy and stores it in prior. It sends the current ID. So transactions can nest within core. Core moves into a loaded state. So that's all there is to it. It's pretty simple and straightforward. Now, the other thing we have is high frequency channels. So we talked so far just about kind of a regular communication channel. A high frequency channel is any event where the expectation is that the events are going to be coming faster than we can actually process them. So a canonical example is sliding a slider. Okay, you're sliding a slider or painting with a brush, right? Things like that. These devices can generate 120. They can read the position of your pencil 120 times a second. Right? So you'll get this slew of events coming in. And what we don't want is to have this high latency as you go and process everything. We don't want you to slide the slider and then you let the slider go, and the image keeps adjusting for 30 seconds after you're done with the slider. Right. So anything that has that property, we open up a high frequency channel. So some examples are things like screen update requests, property value changes by slider, painting. What happens here is upon the initial event, a coroutine is created and sent to be processed on the core. And then a direct communication channel is established from the sender to the coroutine. So subsequent events go directly to the coroutine. Coroutine manages adapting the performance requirements of the string. Right? The most trivial one is take the latest. Right? If you're sliding a slider, you might just say, take the latest value. I don't care about all the in-between values. Just take the latest value. Right? That's probably the most common strategy. That would not work well for painting. For painting, you want to coalesce the values. The other thing that we can do is we can do things like start processing in preview mode. So we can dynamically adjust resolution and quality of rendering based off the stream of requests that we have to do the rendering. We can also cancel operations that are no longer necessary. Right? So if we've started doing something and then we receive another event and we're like, okay, we don't care about that at all, we can just kill it. Right? Free up those resources and move on. And finally, we can defer lower priority operations until things settle down. So the strategy is all time-based to maintain high frame rates. So instead of doing things like I see in a lot of apps, it's like when you mouse down on or finger down on the slider and start moving it, we drop everything into a low quality mode. That can make it very difficult to do a fine adjustment. Right? But if you do it all timer-based, then it's like if you're moving the slider rapidly, then we're doing low quality renders, but as you slow down, the event stream calms down, and now we can do higher quality renders. So the strategy is to maintain the frame rate, not user-based events like finger up and down. So to give you an example, we don't have C++ 20 yet to do it with coroutines. So this is a manually written little coroutine to just take the latest value. So we can walk through this. Let's look here. This is the internals for the most part. This is the coroutine part. Split it down. To handle the communication, we've got a mutex around a bool and our value being sent down. And a task that we can execute. So we construct a receiver with the task that we want to be executing on the other side. To send it a value, we just acquire a lock and set the value internally, and then we return this flag whether or not we've already been queued for execution. And then to invoke the thing, we set our queue to false, we extract the value under the lock, and then we apply outside the lock the task to the value. So to drive this thing on the outside, we need an executor, which is our execution context. Where do we want this coroutine to get executed? And a shared pointer for the shared state held internally here. That's our receiver. So our constructor here, we construct it with an executor and a task. And then this thing looks like just a regular function object that can take a set of arguments and forward them to that task. And then we've got a little convenience routine to make one of these so that you don't have to specify all of the template arguments. So this is what this would actually look like in practice. You can say, oh, make us a function f, which takes just the latest values, executing them on, and executes this task on the serial queue with the latest values. Okay? So all that we're going to do here is print them. And then we're going to drive it really fast. We're going to spin a loop from 0 to 3000 as if the user just whipped the slider across the screen and said, print all those values. And if we were to execute it, this is what it would print out. Right? It would do the best it could to keep up. Will complete roughly the same time it takes to execute that loop. So it's skipping a bunch of values. It's just taking the latest one. But you'll notice it will always end on that value, right? That's the end of the range. That's the last value that's sent. It will always finish executing it. All communication with client happens then on the client thread. So the client of the mantle here doesn't have to worry about the whole asynchronous nature of what's going on with the core. In fact, their model of the world looks very synchronous. If they set a value and read the value back, they get back the same value they just sent. Right? So from the programming model, everything looks like it's just everything sequential, everything happens immediately, everything works great, except for we've got some notifications coming in on the edges, but they're all coming in on the client thread. The core and mantle themselves now are packaged up as a library. And the first client of that library that we'll be shipping will be the iPad product. Which brings us to the Surface. Right? The Surface is now, for the most part, the platform-dependent part that gets built up around this model. Right? But it's relatively thin. It doesn't have to contain all of that logic and all of those behaviors. It doesn't contain any logic in the mantle that says, like, when I hide the layer in this layer group, that implies that I'm hiding all the sublayers within the same group. Right? All of that logic exists over in core. They just bind against it. And from a programming model building up this UI, you just say, hey, tell me when something changes, I'll construct the UI, I'll tell you when things change, go set them. Keep all the logic out of the UI. So it binds to the mantle. The model behaviors are all driven by the core, which brings us to our display system. The display system here I originally wrote for a product called Revel, which was a consumer version of Lightroom, effectively, before Lightroom Mobile. A lot of the code now is used in Lightroom Mobile. In fact, the same display system will be used in Lightroom Mobile. And it can run quite well on the web, although I don't think they're actually using it right now for the web product. And it's basically this, it's a similar model to what we've been talking about, but now the roles of core and surface are reversed, right? We have a high frequency stream of data coming up from core, blasting out to the surface. So what do? We keep a background layer that's roughly screen resolution of the entire document, and a foreground layer that's screen resolution of the visible area of the document. There's an asterisk there because the resolution may be adapted to maintain frame rates. Okay? So this is a sequence of slides I did. This is what Revel actually looked like, but it's exactly the same code that we have running in Photoshop here. We can walk through, explain it, right? So even though you're looking at a piece of the image, right, if you could look kind of behind the screen, right, we've got a low resolution version of the entire document. Sitting on top of that, we've got a higher resolution version of the piece you're looking at. Both of those are projected into the same document coordinate space. Okay? So if you pan, you will see blurry pixels. So if I made some adjustment, like sliding the slider here, then what happens is I've got a coroutine running, driving my rendering. Okay? I've got this high frequency stream coming up, requesting a bunch of values. Right? So I say, okay, my screen's been dirty, my screen's dirty, my screen's dirty, my screen's dirty as a result of sliding the slider. So I would turn around and call the core and say, give me an image. And I'm waiting, and I'm like, you took too long. You blew my frame rate. Cancel that operation. Give me a lower quality image. Yeah, right? So the core sends up a blurry version of the image that I'm requesting. And then, as the stream comes down, I can refine the image until I've got the high quality image. And then I go and I generate the background to match. Now, if the user pans, so what happens from a programming side is, like I said, core animation basically tells me where that animation for that pan is going to stop. Okay? So, knowing where it's going to stop, I have these blurry pixels in motion. You can't focus very well on blurry pixels. So I start rendering where we're going to be. Right? It's the Wayne Gretzky theory of keeping up. For people who don't know, it's a hockey reference, right? Wayne Gretzky once famously said the reason why he plays hockey so well is because he skates to where the puck is going to be. Right? So we do the same thing. We start rendering where the animation is going to stop. Now the animation might never reach there. The user might be swirling around with their finger, right, and it might change direction, okay? But that's okay. Where whatever frame comes in, we'll slap it in the right coordinate space, and you'll see a piece of the updated image, okay? Against the blurry pixels that are moving, you'll never notice. So we'll race ahead and write it out. So, Photoshop on the iPad. Our goal is to bring Photoshop to new devices and new customers. To make it fast, fluid, and fully compatible with the desktop product. We are now, for more than 9 months, the mobile team merged with the full desktop team. We are not on a port. We're on the same code base. Code that gets checked in to desktop Photoshop immediately benefits us. They recently overhauled their undo model, and we picked all of that up for free. So all the work that they're doing, the GPU optimizations that are going on desktop, we're picking up on mobile. So it's one unified shared team. And the whole thing's enabled by really just a few simple ideas, right? This idea that if you had a legacy application, that you can capture the model by just stripping away the visuals of the UI and swallowing the thing whole. The idea that even though you have something that's largely a single-threaded app, you could put that off on its own dedicated thread. And then you can speculatively execute against that to give the illusion that everything is very fluid and fast.
Have all these changes been back into the desktop model too?
So we have not like redone the desktop model to like put the core on its own thread and all of that. There is some discussion going on about whether or not we would want to do that and when we would want to do that. The challenge there is rebuilding the whole UI. That's the biggest challenge in the mobile device here is Photoshop has a massive UI. It's like, over 10,000 strings that get localized in Photoshop. So kind of reconstructing that UI bound against the new model is time-consuming. For some definition of time-consuming. I'm kind of amazed. I walk in every day and people are like, hey, look, I lit up this feature, I lit up that feature, right? But there's just so many features. That's a long pull. So we haven't done that, but kind of under the hood, all the architectural changes that we've been making within core itself, all of those have benefit desktop, and a lot of the changes that desktop has been making have been benefiting us. Everything's quite well coordinated, so I'm pretty pleased with how the teams put together.
Are there any cases where you have to reflect an error back out from the core?
Yeah, so we do. I mean, we marshal exceptions across the boundaries. So Photoshop uses exception handling to throw errors. It's kind of a fairly cute little scheme where at the point that you throw the exception, that tells you what went wrong, and then as it percolates up the stack, that exception gets decorated with what you are doing. So you always get an error message that says, Photoshop couldn't do blank because blank, right? So we pick up all of that information and we'll reflect it back to the Surface side. And like if you did some operation and you were out ahead of the app, then the UI will just correct itself. Usually about the same time that exception comes back, the UI will just correct itself back to the state things were in at the point the exception was thrown.
So if you did like a file save and then you edited a bunch of objects really quickly when you deleted them, and assumed that they were all going to succeed, but then the save failed.
And then the save failed, yeah. You could get that, but you could get that save in desktop Photoshop as an asynchronous operation. So you can get that also. So in which case, it won't roll back your document in the case of the save. It will just leave your document in the state it is in now, but let you know why the save failed.
How old is the Photoshop code base? When was it originally developed?
Well, so Photoshop 1.0 shipped in 1990. So next year is our 30th anniversary for Photoshop. It was shipped as a product called Barney Scan, I think 2 years before that, so 88. I think development initially started in 87. So to give you an idea, in 87 when Thomas Knoll started working on it, his machine was a Mac Plus, so he had a black and white screen to start working on Photoshop. And he did it so that he could test algorithms for his master's thesis. He was working at the University of Michigan, working on his master's thesis, which he never completed. Originally written in Object Pascal. So 1.0 shipped in Object Pascal, 2.0 was ported to C++. So it's been C++ kind of ever since. Originally written using MacApp, which was an old Apple framework, MacApp, an Object Pascal framework. There's still Object Pascal and MacApp isms in the code. So, somebody asked the other day why a whole bunch of our files start with a capital U, and we said, well, that's for an Object Pascal unit. Yes, there's some legacy in there. The team over the years, I was I think the 8th person to work on Photoshop at the time that I joined. There were 6 people on the team, so I initially worked on Photoshop and joined in '93. The team is probably, for the most part, covered around between 12 and 20 engineers, so relatively small for the amount of revenue it generates. We're $2.5 billion a year now in revenue, something in that order. We're in the middle of ramping that up because, like I said, this is a library, so I'm just going to leave that open-ended. But I think we're targeting right now about 30 engineers. My team.
As I notice, you use relatively latest standards of C++.
Yes.
How do you manage migration to the newer standard?
So, yeah, so it took Photoshop 5 full years to move to C++ 11. And it was this insane process because there's a bunch of shared tech components that were getting built by other teams inside of Adobe as DLLs and they get delivered, and so everything had to be coordinated so that all of those dependencies moved up to the latest language, and that whole process to get Photoshop to C++ 11 took 5 years. Right. Next slide. When we started this project for Photoshop on the iPad, one of the first things we did is none of the shared technologies that we relied upon were ported to iOS. Certainly weren't in any portable format. So we went around and broke a bunch of rules and got sources to absolutely everything. And poured it all in and compiled it and sorted through a bunch of the overlapping dependencies and tried to reduce them down to we had shared dependencies. And instead of having 5 copies of zlib, how about we just use the one that shipped with the OS? So now I think we're down to maybe 2 or 3 DLLs that we haven't managed to get rid of yet that are stuck in the project. The nutty thing is we're built from core. We have very little turned off. Initially, we had 3D and video turned off in core. We still have video turned off for the mobile port. Although in theory, we could turn it back on because it's the same engine that Rush is using. Rush is kind of the mobile version of Premiere, our video editor. And the 3D stuff got turned back on in core because an augmented reality product called Arrow was making use of that. And so they went ahead and did the work. All of the 3D stuff turned back on. So very little is turned off in core. And our package, when we deliver it to the App Store, is about half the size of Photoshop Express, which is the toy application that we've been shipping forever. The App Store. So to put that in perspective, we're about 75 megabytes as our full package. Pretty small and tight.
You need the code in Swift?
No, none of the code is in Swift. Like I said, our UI layer is, some of it is Objective-C++. A lot of it is C++. We have kind of a funky database-driven framework that we've done to drive our front-end UI. So you write our UI in terms of YAML descriptions that we fed into the database. That would be a whole separate talk. It's not my work. It's an interesting piece of work. very bottom of that does all plug into platform things. So when you see me panning things around, that's a UI scroll view in iOS. Just their stock toolkit controller. Our list of palettes is a stock table view from iOS. At the very bottom of it. And that's all written in Objective-C++. People know of Objective-C. Not a lot of people know that you stick an extra M as your extension. So instead of the .m file, you make it a .mm file. Then the compiler will compile it as C++ and Objective-C. And the two actually interoperate quite well. So destructors execute when Objective-C objects disappear, and Objective-C ref-counted pointers behave much like smart pointers. You can stick them in a lambda and they'll free themselves when the lambda destructs. And so all of that works quite well. And since our UI layer is thin, it doesn't make a lot of sense to get to Swift. We would have to bridge the C++ into C or Objective-C so that we could get to Swift. Well, if we're going to go to Objective-C, then we're done. Nothing bad against Swift.
Okay, so what standard version are you using? Are you 17, 14?
Oh, so right now we are 14, hinging on 17. Apple's Apple's compiler support is there. Their standard library support isn't quite fully there for C++ 17. And kind of the Venn diagram, it's a shared code base across all of our platforms. The Venn diagram doesn't quite have enough overlap for 17 yet to light it up. But that will happen soon. Now that we pull in everything from source, we kind of changed the way the whole development model works. So we basically have forks of all the sources for all the shared technology. And when we want to update the compiler, we update the compiler and we change all of our dependencies and we send them pull requests. Go fix this stuff. So we are current on, or we're updating tool sets like almost daily with the number of targets we have right now.
Yeah, my question was also oriented. We have also a really old code base, and it took a flight to the nail to get to C++ 11, and that thing is short. There's where we're stuck in the fun. So since you mentioned library, you mentioned the word library there. That's our big thing, right? The big problem is that our code is mostly uses libraries from third parties. So how do you guys handle that transition to move? I don't know, but from the technical perspective, right? As an engineer, well, you see that there are certain advantages here or there, and that's why you want to go to a more modern version.
Yes.
But with the higher up, sometimes it's hard to make them see that, right?
Yes. Yeah, and not from a technical standpoint, but this has been, for me, kind of interesting because I was engineering manager on Photoshop 5 timeframe, and I took over for Mark Hamburg, who had been engineering manager for me, and kind of traded off for a number of years there. He was manager. But one thing I learned from Mark that I applied when I was manager of the team was the question would come up is how much of your engineering resources do you put behind just maintaining the current code base versus adding features? And Mark's answer to that question was, well, it's got to be at least 60% to maintain the current code base. And his rationale for that was that it's easier to make a mess than it is to clean it up. So you needed more than half your people cleaning things up. So I followed that rule when I was on the team and when I was managing the team. And then, I left for a number of years, like 20 years in the middle there. And at one point, one of the engineering managers said, "Oh, I'm so proud, right? I've increased the number of resources that I have to maintain the Photoshop code base to 10%." Okay, which I thought, wow, that's a really bad sign, right? Like things are going to be in decay. When we did mobile, we started with a very small high caliber team. We kind of completely changed the way we did development so that we could move faster, so that we could drive these devices. And if you've ever done mobile development, especially on iOS devices, it's like if Apple releases a new version of the OS, all the devices update automatically, and if you're not running the latest version of the tools, you can't debug on those devices anymore. Right? You can't connect to them with a debugger. So it's this environment that just forces you to get on top of things like that. And so we invested heavily in that, and just kind of a huge amount of emphasis on process and code cleanliness and applying tools to the problem and getting continuous integration servers and unit test servers. There's an open source project that a couple guys on the team started called Hide, which I don't know if you've used Jekyll, creating GitHub pages in Jekyll. So we wrote a tool called Hide, which is a Clang-based tool that will generate boilerplate, nice-looking, the C++ reference, wiki-style documentation boilerplate for your code. But more importantly, when you check in a new API or change an existing API, if you don't update the docs, you don't pass continuous integration. You don't get into the code base, right? So now all of a sudden our docs are up to date, moving rapidly, right? So we just kind of made all of these changes so that we could run faster. And then when we ran into the Photoshop team, all the desktop guys, I expected this huge amount of pushback, right? I mean, these are guys who I've worked with, and it's a very stable team, right? These are people who've been at the company, some of them longer than I've been, and I've been there 25 years. So I expected a lot of pushback. Instead, they were like, oh, please, like, come in and like nuke our process and change how we do things. And management was incredibly receptive, and they were like, yeah, let's just do this, right? They're like, we've been complaining for years that Photoshop can't move fast enough. You guys are moving. Let's nuke everything and change it. So huge surprise to me, but it's been going incredibly well, incredibly smoothly. And now we have things like we can run plain tidy on a code base, and we have plain format for formatting our code, and we can update tool sets like that. Our build process is pretty slick. We've moved from Perforce into GitHub. We're using Artifactory for downloading pre-built components. So you log in the morning and you do a pull from GitHub. You run a script that pulls down all the dependencies from Artifactory and rebuilds your projects. For various reasons, right now we're in a weird mix of Git and CMake. But as opposed to manually maintained projects that they were before, all the projects get rebuilt, and you can hit one button and you can build out all the targets. And when you submit your pull request, it fires off 40 servers and runs through all the continuous integration tests and builds against all of our targets, runs all the unit tests, validates that all the APIs that have changed have been documented. So it's a different world. So I don't know where you're coming from, right? Some of you are probably like it, right? But yeah, for some of us who have been living in kind of a 1990s environment for a long time, it's a big change.
Sometimes it feels like the 80s from this time.
Yeah, sometimes it feels that way.
Any more questions?
More questions?
How many people do you hire for Photoshop?
So right now, if you go to photoshopshiring.com, it lists the open recs. I think right now we have 8 or 9 open recs. Not all of those are C++, but probably 4 or 5 or something plus.
How many in Seattle?
How many?
How many in Seattle?
Oh, in Seattle, right now we've got people in India, in Australia, in Florida, in Pasadena, in Seattle, in San Francisco, in San Jose. Minnesota. I don't care where you are.
No, I mean, how many do you hire in Seattle?
In Seattle, there are 5 open recs. You know, if you're in Seattle or Australia, I don't care.
So do you mean it's okay to work remotely?
Yes.
So you mean that all 5 can come from Seattle? If you find 5 good guys here in Seattle,
Then all 5
keep
come from
all five,
Seattle.
Yeah. They're not assigned to a specific geolocation.
Yeah. It probably says on the recs, it's like, we would prefer you be in, what's a half a dozen places.
And there's no requirement to be on site?
One of the key contributors, well, I would say 2 of the biggest contributors on the team right now. One works out of his house in Pasadena, and one usually works out of his house in Sydney, Australia. But we do have a small office that's not an engineering office, it's a sales office in Sydney. So sometimes we'll go into the office in Sydney, since there's no other engineers there. Adobe historically, a little less so now. We've grown through acquiring companies. When we acquire companies, we usually keep their engineering offices where they are. So we end up with engineering offices scattered. And because we've gotten pretty good at working with remote people, we've used that to our advantage in hiring against companies like Microsoft and Facebook and Google, where they say, you know, if you're going to work here, we want to see your face in the office every day. We tend to say, if you're you know, a stellar individual, we don't care where you are.
What's next?
What's next?
Yeah.
So what am I doing next? So probably going back to a project I was working on before. The way I've been pitching it, you know, this is what's next for me, is to work on semantic UIs. Although I'm super proud of what we've been doing here, I can also give you an earful about what I think is wrong about what we've been doing here. You can look up, I've given some very old talks. I gave like a Google Tech Talk in 2004, I want to say, time frame, titled The Possible Future of Software Development. I was looking at something called property models, which is a rule-based system for how you describe interconnections between properties. And I've published a number of papers in that space, and adjacent spaces. And the whole idea is to try to look at how user interfaces are developed as a language problem. As you know, in a programming language, I mean, equivalent to spoken language, right? How you communicate with your computer is a language. And too often UI design is approached not as a visual and gestural language, but as fashion. As what color are the pixels and where are the pixels. And so I want to turn that around and say, no, how do we go about doing UI design from a semantic standpoint? So that will probably be what I go on with next. This product will ship, we've said publicly in the middle of this year. I will probably stick around on the team at least till the end of the year. And whether or not my new project is me starting a new team or working on the side or working within Photoshop, I don't know.
Is that related to the Adam and Eve stuff?
Yeah.
And ad hoc networking theory? And,
Yep.
How much new code was it to run?
Less than you would think. So the reason why we went after iPad first was because some of the frameworks match the Mac frameworks. So they were already shipping on Mac. That gave us a little bit of a leg up. There's a library version of Photoshop, which is not like an interactive version of Photoshop. It's like we're doing batch processing on servers, but it's still built out of the same code base. PSL, library, very original. That had been ported to Linux, so there was some Linux code that we were able to borrow. Just kind of POSIX code that came over fine for iOS. Photoshop 3 shipped on Sun and SGI Unix systems. Believe it or not, that code was still in there, so we stole some of that code. There were places where it was like, oh, well, we need a portable version of this, whatever this Mac thing was, and it's not available on iOS. And we would look and say, oh, look, we wrote this for Windows, and so it's in a file that's labeled, whatever underscore win, our naming convention for Windows-based files. But it actually has no Windows dependencies in it. It's just a portable version of whatever the thing we needed was. So we pulled that stuff in. There was, since we were stripping away the whole UI layer, right, there was not a lot of new code that we brought up. Right? Most of the new code was in this mantle layer and in the new surface work. But the mantle, the goal with the mantle is to be thin. So it's a small number of small constructs that just compose together.
One more question? Wow.
Okay.
Going once, twice? Thank you very much.